Welcome to The Explainer. Today, we're going to talk about a massive revolution that's happening kind of behind the scenes, changing the internet as we know it. We're moving away from a world where one tiny typo could literally bring down an entire network to a future where networks can build, heal, and pretty much manage themselves. So let's get into it, the big shift to network automation. Okay, so here's our game plan. We're going to start with the why. Why automation became totally necessary. Then we'll peek under the hood of a network device, learn the common language that makes all this possible, check out the key protocols that deliver the instructions, and see it all come together with a really cool real-world example. And finally, we'll look ahead to the future, the self-driving network.
So, first up, the automation imperative. Look, every major tech leap happens because there's a problem that just can't be solved the old way. And for networking, that problem was, in a word, scale. The old way of doing things just completely fell apart.
I mean, just think about this for a second. 500 new switches, 20 different sites. The old way, you'd have an engineer with a laptop literally plugging a cable into every single one of those devices, one by one, and hand-typing hundreds of lines of commands. Not only is that mind-numbingly slow, but it's just begging for human error. It's a recipe for disaster and costs a fortune. That way of working just doesn't fly anymore.
And this is the bottom line, right? The manual approach is a huge bottleneck. It's slow, and like I said, one slip of the finger can cause a major outage. But with automation, the difference is night and day. You get lightning-fast deployments, you know every device is set up exactly the same way, and your security is way stronger from day one. All right, on to section 2, inside the network device. So to really get how we automate these things, we got to take a quick look at how they're built. These boxes aren't just one big blob of technology. They're actually organized into 3 different planes, and each one has a very specific job to do. The easiest way to think about this is to imagine the device is a robot. The management plane, those are its ears. It's how we give it orders. The control plane is the brain. It's constantly learning and building a map of the network around it. And the data plane, that's all muscle, the heavy lifting hardware that moves your data at incredible speeds. Now, for automation, the key thing to remember is that our tools talk directly to the ears, the management plane, to tell the whole system what to do. Okay, so if we want our automation to work with gear from different vendors, Cisco, Juniper, Arista, the whole lot, all these machines need a shared standard language. And that common language, that Rosetta Stone for networking, is called Yang. So that definition sounds pretty academic, right? But put simply, Yang is just a universal blueprint. It creates a standard template for how to describe any feature on a network device. So whether you're setting up a basic IP address or building a super complex security policy, Yang gives you a structured, predictable format. And what that means is your automation script can speak the exact same language to a Cisco box as it does to a Juniper box. It's a game changer. And this quote from the folks at the IETF just nails it. This is its whole reason for being. It takes us from a world of vendor-specific chaos, where everyone had their own way of doing things, to a clean, standardized foundation. That consistency is what makes any kind of large-scale automation even possible. Okay, so we've got our standard blueprint with Yang, but now we need a way to actually send the instructions to the device. Think of it like a postal service. And the 2 main players, the 2 dominant protocols for doing this, are netconf and restconf. This table breaks down the differences really well. Let's focus on a couple of key things. Netconf, you can see, was built by network engineers for network engineers. It runs over SSH, uses XML, and it has this killer feature, full transactional support. That means you can send a whole batch of changes, and if one little thing is wrong, you can roll the entire thing back. It's super safe. RESTconf, on the other hand, was built for the web world. It uses HTTPS and JSON, which every web developer already knows. It makes it incredibly easy to plug network data into dashboards or other apps. You basically trade some of that robust, all-or-nothing power for simplicity and flexibility. Okay, enough with the theory. Let's put all these pieces together and see how they work in the real world. This brings us to one of the absolute coolest and most powerful uses of network automation, getting a brand new device, fresh out of the box, online and fully configured without a single human keystroke. It's called zero-touch provisioning, or ZTP. This is where the magic really happens. A technician in some remote office can literally take a switch out of its packaging, plug in the power and a network cable, and just walk away. That's it. The device does the rest all by itself. So how does this magic trick work? Well, when that new device powers on, it basically sends out a shout to the network saying, "Hey, I'm new here. What should I do?"
A server on the network, using a protocol called DHCP, answers back. It gives the device an IP address, sure, but it also gives it this super important piece of information, a pointer to a provisioning server. The device then uses that address to connect, download its software and its exact configuration file, reboots, and boom, it's online and ready for action. It turns what used to be hours of manual work into a hands-off 5-minute process. So now that we have these foundational building blocks, things like ZTNP, the Yang language, and modern protocols, the entire industry is starting to look towards an even smarter, more autonomous future.
And this is where we get to the holy grail, the self-driving network. The huge shift in thinking here is moving from telling the network how to do something to just telling it what we want to achieve. We stop logging into every device and configuring routing tables. Instead, we just state our business intent. We say something like, make sure all video calls from the CEO's office always have the absolute highest priority. And then the network, as one big intelligent system, figures out how to make that happen, constantly monitoring and adjusting itself to make sure our intent is always being met.
So when you look at this final question, it becomes really clear that network automation is about so much more than just saving time or being more efficient. It's not just about doing the old things faster, it's about making entirely new things possible. We're building an intelligent, self-healing foundation that's going to power the next wave of innovation in our crazy, connected world.